Welcome to Solving Rational Equations. Let's get started. So before, when we solved linear equations, when we solved them, we're looking for the point where they cross. That was the solution. That's how we solved linear equations. So we want to do the same thing with rational equations. We're going to have two different rational equations. So here's an example here. Here's one of them. Okay, so if we had two different rational equations, this is where this one crosses. And we would want to find that point. So that would be solving two rational equations. Where's their intersection? Same as when we did linear. So this is what we're doing graphically, is when we're going to solve it algebraically, but this is what it means, is that we're finding two rational equations and we want to know where they intersect, where they cross. So following along with your notes, still we're working with rationals and we usually want to factor. So you can see this is already, if there's nothing to factor here or here, but we do want to factor this binomial. So we can factor that to n plus 3 and n minus 3. Now, something else that you want to look at that's a little bit different is to find an exclusion. Remember, with a fraction, and these are all fractions, you don't want 0 to be on the denominator. It can't be on the denominator. So if you look here, we have n plus 3. So n plus 3, that bottom on the denominator, it can't equal 0. So this right over here can't equal 0 either. That's what they mean by exclusions. So you solve for n. So we said those can't equal 0. So that means n can't be negative 3. And just like over here, the same thing, n cannot be positive 3. So that's what they mean by exclusions. Because if n was positive 3, then when we went and plugged it back in, 3 minus 3 would be 0. And we can't have a 0 at the bottom of a fraction. So your exclusions are, what you do is you make the denominators equal to 0. And you solve. And those are the numbers that your variable cannot be. So n cannot be negative 3 and it cannot be positive 3. So no matter what we get when we do all this work, if it turns out to be negative 3 or positive 3, that's not an answer. It's not a solution. Okay, so this is something that you kind of have to find off on the side. Now let's come back to here. We factored it. Now we want a common denominator, but we want a common denominator for all the terms on both sides. So that means this has to be n plus 3 and minus 3, this needs to be n plus 3 and minus 3, and this needs to be n plus 3 and minus 3. So I'm going to use a different color over here. And what I'm doing is putting an n plus 3 here, and whatever I do to the bottom, I have to do to the top. This fraction is missing an n minus 3. Whatever I do to the bottom, I have to do to the top. So now I'm going to rewrite my new equation down here. And I have n minus 3 times 1, which you don't need to write. And then I've got my new common denominator. Plus, and I didn't do anything to this one because it already has an n plus 3, n minus 3. So I didn't need to change anything with that fraction. Equals 2 times n plus 3. If you like the parentheses, you can leave them. And our new denominator, n plus 3 and minus 3. So see, we've got the same denominator across. So we did what we wanted to do. Now when you have a denominator, when they're all the same, when you have all the common ones, you can just cross them out. So that's why we want to get them the same, so we can get rid of them. And what we have left is just the numerators. So n minus 3 plus 5 equals, and we can distribute this, 2n plus 6. So now I have a much simpler equation to solve for my n. And I can do this here, combine my n minus 3 plus 5 is n plus 2 equals 2n plus 6. And then I'm going to subtract my 6 and get n minus 4 equals 2n. I can subtract my n, and these cancel, and get n equals negative 4. And here's where you have to be a little careful. N is negative 4, but you have to go back and look at those exclusions. It's okay because in this case, because n can't be negative 3 or positive 3, and we're saying that n is negative 4. So that's okay. So we have an answer. N is negative 4. So remember what we did. We factored. We made all the denominators the same so we can cross them out. And then we had a much easier problem to solve. And don't forget to find those exclusions. In this case, it's all right. We ended up with an answer at negative 4. So let's do one more example together. So the first thing you want to do is factor, if necessary. We don't have anything to factor. None of these polynomials factor. So we're good on that part. We want to find our exclusions. So we take our denominators. In this case, they're actually already the same. So x minus 3 cannot equal 0. We don't want a 0 on the bottom of a denominator. So we solve for x. So x cannot be positive 3. Okay, so that's an exclusion. Now we go back and we're solving for x. Find the common denominator for all terms on both sides. Again, lucky us, they're already the same. So we don't even have to worry about that part. Once they're the same, you get to cross them out. So now we just work with the top, the numerators. So 3x equals 2x plus 3. And actually, I don't want to do that. I meant to subtract the 2x from both sides. So this will cancel, and I end up with 3 minus 2x, which is x, equals 3. Now, here's where I said again, we want to check. We said that x equals 3. We found it algebraically. But our exclusion said that x cannot equal 3. Right? Because if you put a 3 back here, 3 minus 3 is 0. We don't want a 0 there. So we actually don't have any solutions. So what I want you to do now is to remember these steps and use your notes to try the examples on the back. It's okay if you get them wrong. We're going to do them step by step in class, but you have plenty of room to try it and make mistakes and then write what we do together in class on the other side. Remember to factor if you need to, find your exclusions, find the common denominators for all terms on both sides, just like we've been doing before with adding and subtracting rationals, and then find x. And then don't forget to check if your answer happens to be one of those that it's not allowed to be. Then we would write no solution. So watch this as many times as you need while you go back and try those examples. That's it. Thanks for watching and see you soon.